Okay, so two fundamental rules of algebra. And it's this. So rule number one is if A is equal to B, then A plus C is equal to B plus C. Good? So this is called addition property. Yeah, very good. Thank you. Yeah. Okay, so rule number one. Now, rule number two is if A is equal to B, then A times C is equal to B times C. So this is called multiplication property. Okay, so as far as this to do with the equations, we either add the same thing on both sides and we multiply the same number on both sides. And also in algebra, remember algebra, we learned about numbers. Numbers. Now numbers, we have different kind numbers. And the first kind of number is we call that natural number. And it's also called counting number. So we got two names for that, counting numbers. Now, basically is what we had 1, 2, 3, 4, and 5, and keep going. That's we learned pretty early on. And now, the next number is called integers. So that's where we got, oh, uh, okay, actually before the natural numbers, or before the integers, we have a number called whole number. And that just basically adds 0 to the counting numbers. So 0, 1, and 2, and 3, and 4. And then we got integers. Now, integers, so we got negative now, -1, -2, -3, and 1, 2, 3, 4. That's integers. And then the next number family is called rational numbers. Rational numbers is it includes so rational number. Now rational number, it has something like say 2/3. It's not integer anymore. So this is a fraction, and so because the fraction is we see that in our daily life. So we have to have a name for it. So the name is, we call that rational number, and the rational number also includes integers. Okay, so what's the definition of rational number? Definition of rational number is that any number you can write as a quotient of integers. So for example, this is a 2 divided by 3, which is 2/3. That's a quotient. That's what quotient means. And well, if we have a number like say 2, well, 2 we can always write as 2 divided by 1 and 4 divided by 2. So therefore, any integers are also we can write as fractions. So they are all belong to the same family. It's called the rational numbers. And you can see that number family getting bigger. So we started with a natural number, and we got whole number, which is add 0 to it. And then we got integers. That means we're going to add negative. number to it, and then we have rationals. So rationals, we're going to put in fractions into the integers, so the rationals. And for a while, people think that's all the number there is. There's no other numbers. Well, until people start to see this. We know this is called Pythagorean theorem. So what they said that if this is 1 unit, this is 1 unit, what happened to here? This is square root of 2. Well, square root of 2 have a problem is that no matter how hard we try, we cannot turn that into a fraction. And of course, eventually, the mathematicians proved that square root of 2 is indeed not a rational number. You can never write it as a fraction. So then we have to give a name to that because there's something new. And name give to that is called the irrational. Well, since we have rational numbers, the other numbers are called irrational. Okay, it's not that they're become crazy, it's just like it's not a rational number. So give the irrational number. Well, it turns out that we have plenty of irrational numbers. So like square root of 3 is irrational, square root of 5 is rational, and square root of say 11 is irrational. Turns out that we have plenty of irrational numbers. Actually, we have a lot irrational numbers. So now, but we don't call them as its own number family. Remember, our family just growing from natural to whole to integer to rational. So what we're going to do then is we come up another family, number families. We call them real numbers. So now we add one real numbers. Now real numbers, that means we got all the rational and plus irrational numbers. But, so this is basically what we're dealing with in Algebra 1. Algebra 2, we're going to learn something called the imaginary number. But as far as Algebra 1 goes, we just got to this part. But we need to understand the nature of that. We can see that the natural number is also called counting number, is something we learned pretty early on. Just like we can count things, we got 1 and 2 and 3, and then we got a whole number by adding 0 to it, which is new. It's something, well, not new. It's how do you say that? It's a step up. Okay, to understand 0 actually is number, because for a long time people don't think 0 is number. 0 just means nothing. Well, now nothing actually turned out to be also a number, so that's a big one. And then we find out, okay, we can have negative numbers, so that's integer. Then we look at, okay, we can throw in the integer and plus fractions. Well, that become our, so that's integer plus fractions, and that's called the rational numbers. Now we see fraction numbers every day, right? We share, like say a pizza. Maybe we got slice of apple or slice of watermelon. Those are not whole. That's just a fraction of it. Okay, so that's the number we learned. All that, and because the number we're dealing with in algebra, we're dealing with real numbers. And because we're dealing with real numbers, that means our numbers can have positive and negative. So therefore, when we're looking at our fundamental rules, and we see that we can actually make our life a little bit easier. Like, for example, number 1, even though we say addition problem, but that also includes, for example, if we have, say, 3x plus 4 equals to 9, we can add number to it. Well, we can also minus number to it. But realize that we have negative numbers. So therefore, we can turn the subtraction into addition, except now we're adding negative numbers. So the subtraction turns into adding negative numbers. So therefore, we can just use one rule to cover both addition and subtraction. In the ancient times, they have to use two rules, but now we're just putting at one. Similarly, on this one, in the ancient times, they actually need two rules. One is multiplication, another one is division. Well, because we're dealing with real numbers, so at division, say 4 divided by 5, we can turn that into 4 times 1/5. So therefore, the multiplication property is not problem. Sorry, that's actually called property. The additional property and multiplication property, they are both property. The addition property can cover subtraction. The multiplication property can cover division. Okay. Okay, so now at this point we say, okay, well, we know we can add same thing on both sides. We can multiply same thing on both sides. So, though, well, that works for any number. So, what number should we add? What number we should multiply? So that actually gets into um, something about the properties of addition and subtraction, and also with numbers. Okay, we have to understand the properties of numbers, and also understand what is plus, what is multiplication. And so that going to looking at, we have these rules. We put in together. So this is about add, that's about multiplication. So those we got, this is our basic rules. So we talk about two fundamental rules. Now we're going to talk about 10, the basic rules. Okay. And first thing we know that when we add something, the order really doesn't matter. Same thing when we multiply something, the order does not matter either. And now we actually, this is a language of algebra. We use letters. So it actually make a life a lot easier. We don't have to say, when you add two numbers, the order does not matter. It takes a while, but we can just say A plus B equals B plus A. So that makes things pretty clear. And also, people in different cultures, they understand that this actually is the common language that everybody understand it. So this is so we have that. So then we have rules A plus B plus C, and when you add more than 2, well, we have to start with 2. Well, which one we started with, and turn out it doesn't matter. We can add the first 2, or we can add the last 2. So the order does not matter. And this is called associative rule. This top one is commutative. Okay, times as multiplication, A times B times C, and it really doesn't matter which to go first. When we use the parentheses, means we do that first. And so it really doesn't matter which two we multiply. And now we're going to looking at, so we got 4 already. We're looking at when A plus 0, they tell us the 0 is a special number. When you add to any number, does not change. And then we got A times 1 as equal to A, does not change either. Okay, so this is called identity because nothing got changed in it. And then we have something called inverse. So a plus its opposite will equal to 0. So, for example, 5 plus -5 has to be 0, and 7 plus -7 is 0, and it doesn't matter which one. We could have square root 2 plus negative square root 2. That's always 0. And we have actually, this pi is a very important irrational number. Pi and negative pi also equal to 0. So that's why we use this. So any number adding its opposite is 0. And we also have a number times its reciprocal. Any number times reciprocal will equal to 1. So this is the inverse. And last two is what we're going to do with something like this. A times parenthesis B times C, but we're going to break it down is A times B plus A times C. Or we can do A plus B times C, that gives us A times C, and A B times C. So then this is called the distributive. Okay, good. Okay, so now we got 2 fundamental rules and 10 basic rules, and the 10th fundamental rules is the rules about the equation, the equal sign. And the 10 basic rule is about the operator, because these are addition and multiplication. And we said early on, multiplication, when we subtract something, we can just write as add its negative opposite. And when we're dealing with fraction division, we can write as multiply its reciprocal. So therefore, we really just need about 2 operators. So now we can see there's 2 operators and 1 equal sign, equal. And with that, we pretty much can handle almost all algebraic problem. And we're going to learn about inequality next time, but it's just add some to it, but this is basically the rules we have when we're dealing with algebra. So Algebra 1 help us to get familiar with those. And later on, then we can do more, in Algebra 2, we're going to start more advanced problems. Okay, so we have that. Well, let's see how we use it. And of course, simple one is trying to solve something like, say, a plus 3 equal to 5. Now, how do we solve that? And when we say solve the equations, we actually have something called unknown. Basically, when we find the solution of the equation or solve the equation, is really find out what's the value for the unknown. Okay, this is X is kind of like a box. We're trying to figure out what's inside the box. Okay, so the way we do it is always go from here. That's our starting point. And our ending point is always X equal to something. So we have to go from here to here. Now, how do we get there? Well, it's based on the rules we have. So what we're going to do, you can see we had to move 3 to the other side. How do we do that? We can either add or multiply. Now, in this case, multiply does not help us, but we can say we add -3, and this side we add -3. Well, that's our first rule. It's, remember, if A is equal to B, then A plus C equals to B plus C. Now we just know which number we're going to add to it. So basically adding this numbers opposite. So now we got X plus 0 on this side. That's pretty easy. 5 add -3 is 5 minus 3 give us 2. And now we know X plus 0 is just simply X. Well, we just get to this point now. So that we got solved it. Good? Okay. Now we actually can this is a very simple one, but we can actually get a little bit more complicated. Like, for example, we have to do 2x minus 3 equals, let's say 5. So what we do that. And again, we're trying to get to here. And we can now either add or subtract or multiply or divide. So in this case, we want to move 3 to the right side, and which means we're going to add its opposite. And this way we got 2x plus 0, and we got 8 on this side. Well, we know anything adding 0, it just is solved. So we got 2x equal to 8. And then we're going to multiply something on both sides. So we get rid of 2. So what we're going to do is multiply the reciprocal of 2. But anything we did on the left, we have done the right. So that's our basic fundamental rules here. Anything we did on one side of the equation, we have to do exactly on the other side. So now, once we have here, we know a number times the reciprocal is 1x. On this side is 4. So therefore, we know 1 times x is x. So x is 4. So that's how we're solving it. Now, this is called linear equations. There are other equations, but the rule is still the same rule. We either add something or multiply something on both sides. And we always trying to get to the end, that our goal is the same, is to figure out what's value of that unknown. And in this case, we only have one unknown. In other case, we may have 2 or may have 3, but in this case, we only have 1. Good, Mia? Okay, so let's just try a couple of those, okay? So 4x plus 5 equals 7, okay? Very good. So this is pretty simple, straightforward. We just got that. Uh, okay. And of course, we can make dealing with something a little bit more complicated. So, for example, we could have something like, say, 3x minus 2 equals 5x plus 3. Now, in this case, we have this combining they call it combining like terms. Combining like terms. Now, we know all the numbers are like, okay? And we also know that this and this are called like terms. And for the like terms, we can actually add or subtract because both only have x. Now, if you have something like, say, 2x and plus 3x squared, now they are not like terms, so we cannot add them. This is not equal to 2x or 5x, and it's not equal to 5x squared. And these are called unlike terms. We cannot do anything about that. We cannot add them. But here, if you have like terms, what we're going to do, so what we're going to have to do is we got to move the term with the unknown, which is x, on one side. Normally it's on the left-hand side. Okay, so if one move it over, doesn't matter which term got moved. If you move to the other side the equation, we're just adding its opposite. So if you want to add this one, so it's negative 5x on this side, and this is a negative 5x. So therefore, 3x minus 5x, of course, is negative 2x. Then we got this. The other side, they got canceled, 0. And 0 add 3 is 3. So we just write like that. And we don't have to keep writing 0. We'll just 0 plus 3 is 3. Okay, now we have to move this over. So we're going to add 2 on both sides. You can see that no matter what we do, we just either add or subtract or multiply or divide. And then we got negative 2x equal to 5. So negative 2x equal to 5, what we're going to do is times negative 1/2. And so we do the same thing because negative 1/2 is the reciprocal of that. So negative 1/2 times that give us 1. So this 2 multiply give us 1. 1 times x is x. On this side, we'll call 5 times negative half, which basically is 5 over 2. And that's how we can find what x is. Good? Perfect. Okay. And so we're going to looking at, or sometimes we have to, I'll just give you 4x plus 7 equals to 7x minus 3. Okay. Very good. It is because we put minus 7x on both sides, and we got negative 3x on this side. And of course, we're going to add negative 7. Then we got negative 3x equal to negative 10. We're going to times negative 1/3 times negative 1/3. And that give us 1. So we got x. The other side will be 10 over 3. Perfect. Good job. And now we're going to look at the one, another kind of that is when we have to dealing with, we have to separate out the unknown quantity from numbers. So say minus 5 plus 7 equals, let's see, 3 and 3 and x plus 2 and minus 5. So it looks like complicated, but the process is still the same. But first of all, we have to separate them out because remember, our goal is always x on the left, and everything goes to the right. So basically, we have to move things from one side of the equation to another side of the equation. And by the way, the name algebra actually came from Persia. It actually came from Arab, it's Arabic, a language. It basically just means that you move things from one side of the equation to the other side, and that's basically what algebra meant at that time. But of course, today we have a lot more about that. But the fundamentals still the same. We just move things from one side of the equation to the other side. Okay, so we go times that. This is our distributed property. And once we do that, we got 6x here minus 10 plus 7. And we got 3x plus 6 minus 5. Then we can add combine that terms. We got 6x here. That is negative 3 and that is -1. And now back to something we know how to do it. And that's basically a strategy when we do algebra, is always trying to reduce it to something we know how to do before. Any new problems we're trying to solve. Okay, so now we we got to this part, and again we're going to combine like terms. So this has to get to the left. So we're going to minus 3x on both sides. Then of course we got 3x left on one side, and we got -3 and -1. And then, like what we did early on, we're going to move the 3 to the right-hand side. So we're going to add 3, adding is opposite. Then what we got here is 3x, and this side is 2. So we're going to multiply. It's reciprocal. That's how we get rid of this number. So then we got x left, right-handed is 2/3. That's how we find this one. Hello?
Hello, I'm sorry, my phone died.
Oh, okay. Uh, so I'm going to have, let's try one. So let's say 2 times 2x plus 1 and -7 and equals to 3 and 2x minus 4 and plus 3. Good? Very good. Good job. Okay, so now we're actually looking at linear equations uh, uh, and how to use that basically to practice so that we're good with the rules. And now we're going to look at something a little bit different because in algebra, we definitely dealing with equations. So equations, anything which have equal sign, there's all kinds of equations, and the linear equation is the simplest. We also have something called inequality. And basically, we got these two kinds. We're either dealing with equations or we're dealing with inequalities. And inequality is actually sometimes pretty much common in everyday life. If you go buy something, you don't have to be exact. Just make sure you have enough. And sometimes if we wants to make a decision and want to do something, maybe buy when you're getting older, maybe buy a house or buy a car, and you have to look at, do you have enough money to do that? So that's basically just, we don't need to have the exact amount. We just know, do we have enough? So that's basically what inequality does. Now, inequality, the rule for inequality, the first rule is the same and as the equations. If A equals to B, A is less than, so we got, remember, I'm just going to write this for the equation. The equation we have this, A plus C equals B plus C. Now, inequality is if A is greater than B, then A plus C is also greater than B plus C. So that's kind of the same as equality equation. And this is a greater than, and we also have a less than. And less than is basically the same rule. A plus C is also less than B plus C. So just like our first rule of the algebra. So this is that dealing with equations, and this is our first rule for inequality. And our second rule for inequality is going to be a little bit tricky. It has to do with this. For example, say 4 is bigger than 1, but if I'm going to multiply -1 on both sides, what happens? Well, on this side is -4. On this side is -1. Well, but -4 is less than -1. So this has to change when we multiply a negative. So we have to flip it. So that's the only thing when we're dealing with inequality, which is different from equations, is that when we multiply a negative number, we have to flip the sign. Okay, so now let's look at the second rule for inequality is if A is less than B, then A times C will be less than B times C as long as C is positive. So if we multiply positive, doesn't matter. It won't change anything. But when we actually multiply negative number, then we have to flip it. So that's when C is less than. So we got two cases when we multiply. Depends on when you multiply positive number or negative number. If we multiply positive number, then nothing changes. When we multiply negative number, we have to flip the sign for inequality. Now, of course, we could be starting with something is greater than. If that's the case, then A times C is greater than B times C. But in this case, C is, as long as C is greater than 0, we're fine. But if not, if C is not 0, C is less than 0, then A times C will have to flip it times B times C. Okay, so, and the reason we do that is because we look at one case that we have to do that is because it has to do with how the number get whole number line. 1, 2, 3, and it's -1, -2. So on the number line is always the left is less than the right. Because the way how we set it up, then when we multiply negative numbers, we have to flip it. Okay, are we good on here? Yeah, very good. So we're going to just do give some examples. Okay, very simple one. Say x minus 5 is greater than 3. So how do we do that? Well, this we know we can add the exact same thing. We just add 5 on both sides, and then x is greater than 8. So pretty straightforward. And what happens if it is less than 10? Well, same thing. We just add -3, add its opposite. And what we got here is y on this side will be just 7. Pretty straightforward. Good? Okay. So let's just try just couple, pretty simple. And we have this. And what you got? Very good. Again, since we're doing algebra, it really doesn't matter the variable, what kind of variable we use. Could have all kinds of letters. It just means some unknown. It means the same thing. We just kind of use different letters. Okay, let's do that one. Very good. Okay, now we're going to get a little bit more complicated. So 2x greater than 10. So remember, we just multiply half, just like we do the equation. So in this case, that side cancel, we got x greater than 5. So that's pretty easy one because we multiply a positive number. Uh, Now, what happens if it's doing something like this? 3x is less than 15. We know we have to get rid of that. And to get rid of that, we just multiply its reciprocal. And anything we did on the left, we have done the right. But in this case now, we're dividing by a negative number, so we had to flip it. And that become negative 5. Yeah. We good on this? Okay. So now we got into something just a little bit more complicated. For example, we got 4y minus 5 less than 11. So what we're going to do is we're going to, of course, we have, again, everything number has to go to the right. In this case, we don't know is greater than or less than, but one side is the letter, another side will be the number. Okay, so we're going to add 5 on both sides. So that rule is the same as the rule for equations. So we got 4y here, less than 16. Then we times 1/4 on both sides. Now we can see that this side we got y now. And we multiply positive, so nothing changes. So less than 16 divided by 4 is 4. So that's how we solve the inequality. Good? Okay. Now we're going to see one more. Then I have you practice on. So it's negative 3x plus 4 greater than negative 11. Again, we just add the opposite. And then everything become negative 3x greater than negative 15. Now here is, because we're doing multiply the a negative number, and so x is here. We had to flip that. Negative 15 times negative 3 is just 5. So we got that. Okay, good. Okay, so let's just try a couple of problems. One is 5x minus 6 is less than 4. Very good. Then negative 3x plus 7 and greater than -5. Very good. Good job. Okay, let's try our last one. 4x minus 5 less than -3 plus 2x. Perfect. Good job. Good job. Okay, very good. So that's what we have today. So basically, we can looking at the rules of algebra, and which is important. We got 10 basic rules for the operator plus and multiplication, and we got 2 rules for the equation. And we actually also have 2 sets of rules for inequality. And so that's pretty much we have. So we got 10 rules for uh, operators or operations. It's addition and multiplication. Then we got 2 rules for equations, for equality. Then we got 2 rules for inequality. So basically, the rules for equality, and inequality is that we can either add something on both sides or multiply something on both sides. And they are pretty much the same, except when we're dealing with inequality, when we multiply negative number, we have to flip it, the sign. And other than that, there are the 2 rules for equality and inequality are pretty much the same. Good. All right. Okay. So I'll see you next week. Okay.
Okay, bye.
Bye.